Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Please give me a quick +1 in the chat if my voice is clearly audible to everyone and everything is working fine. Then I'll start off with the problem as well. Today's problem that we are going to discuss is really interesting and like it's very easy as well. So please give me a +1 and then I'll directly start with the problem. So hi Rishit and hi everyone else as well. Okay, and make sure to hit the like button and let's get started with the problem now. All right, so let's see the problem. So you can see that the problem was asked in Samsung and it is named as finding the maximum GCD of siblings of a binary tree. Okay, so in this problem, what you have to do is like, first of all, the first thing is that you have to find the maximum GCD. Okay, basically, the first thing is that in this problem, we need to find the max GCD. I hope that the screen must be visible. Okay, so in this, we have to find the maximum GCD first of all. Now, what kind of GCD we have to find? So I'm assuming that you know what is GCD. GCD is the greatest common factor. So let's say if I'm talking about a number, let's say like something like 6, and let's say if I'm talking about another number, let's say 9. So the greatest common divisor of all these two numbers will be, I think, nothing but 3. Okay, so this is the GCD of these two numbers. So you can check for it, other numbers as well. Now in this problem, it says that you will be given a binary tree. Okay, but first of all we have to see that we have to find maximum GCD, right? Maximum GCD of siblings, right? Siblings. So now what is siblings in a tree? Okay, or in general, what is a sibling, right? So let's say there is a father, right? Let's say there is a father and the father has two children. Let's say this is one child, let's say. Okay, and let's say this is the child's two. Let's say this is the second child. So basically both these people, this guy and this guy, these two are sibling to each other. Is that clear to everyone? Please give me a +1 because that is very important. Okay, so if I have the same father, right? If two people have the same father, so basically child one and child two, these two people, these two are the sibling of each other. Is that clear? Like child one is the sibling of child two, right? They are sibling of each other. Is that clear in a tree? Guys, please give me a +1. I hope that this point is very much clear to everyone. Okay, right. So basically, if there is a father, right? So if there is a common father, in that case, or you can say common mother also, in that case, I can say that this is the condition for sibling, right? Now, what does this problem say further? Uh, it says that you will be given a binary tree and the task is to find the maximum GCD of the siblings of this tree, right? So you have to return the value of the node who whose two immediate children have the maximum GCD, right? So let's quickly check out the sample test case for this problem, right? So let's say if we check out the sample test case, right, that is given to us. So let's quickly copy it up. So the sample test case says that we have been given 4, right? After that, we have been given 5 here. Then we have 2 here, I think, and then we have 3 here. After that, we have 1 here, okay, and then we have 6 here, and we have 12 here, right? So if I will see here, like let's see. So for this guy, this is the sibling, like this is the child and this is the child, right? So hi Nitish, I am very good. How are you? So basically, I can say that what is the GCD of 5 and 2, because 5 and 2 are siblings. So the GCD of 5 and 2 is nothing but 1. Okay. Now after that, if I'll see, so 5 does not have any child, right? After that, if I'll see for 2, so for 2, I can see that, okay, 3 is the child, okay, 1 is also the child, right? So what is the GCD of 3 and 1? The GCD is nothing but 1 itself, right? Okay, this is the scenario. Now after that, if I'll see further, so what is like for 3, it has child 6 and it has also a child 12, right? So what is the GCD of 6 and 12, right? The GCD is what? Can I say that the GCD, hi Vanchika, so the GCD for these two numbers is nothing but 6. Is that clear? That the GCD for these two numbers is nothing but 6, right? So out of these, what is the maximum GCD? Can I say that the maximum GCD is 6? Please write 6 in the chat, okay? Please write 6 in the chat and then we'll proceed further with this part. And hit the like button if you haven't already. Is this point clear to everyone till this much part? Okay, please hit the like button, guys. I will highly suggest that you can hit the like button and please write 6 in the chat. Okay, the maximum GCD is nothing but 6. But in this question, if you will see, so the output is nothing but 3. If you will see, observe here. So the output is nothing but 3. Why? Because the explanation says that for the above tree, the maximum GCD is formed from the nodes 6 and 12 for the children, for the child of the node 3. Okay, so basically, if you will see here, you have to return, like you have to return this node, like you have to return the node that is the parent. So basically in this problem, what you have to do is you have to return the actual father, like you have to return 3 because 3 is a father who is having two children such that when they are behaving like siblings, so they have the maximum GCD. So that is why you will return 3. Please write 3 in the chat because I need to return that particular father. I need to return the father, or you can say the mother, whatever you say. Right? Is that clear to everyone? This point is clear, guys. Till this much point, everyone is clear. Please tell me, and then I'll proceed further as well. All right. I hope that this point is clear to everyone. Right. Now, in this problem, there is one more, let's say there is one more scenario, right? So let us say that if I had something like this here, let's say if I had something like, let's say something like this was there, right? Let's say 6 was here. Okay, for one, it had some child. What if there is only one child? I'll come to it. I'll come to that part. I'll come to that part, Rishit, in some time. So let's say one is also there, okay, and one has two children. Let's say 6 is a child and 36 is another child, right? So can I say that the GCD of 6 and 36, right? It will also be equal to what? The GCD of 6 and 36 will also be equal to nothing but 6, right? Now which guy should I return? Guys, please tell me. Like, because if I will see here, right? So should I return 3? Should I return this father? Okay, because these two are having the GCD as 6, right? And these two people are also having the GCD as 6. So which one should I return? Right, that is one another question. Please give me a +1 because that is another point of view that I should see, that if there are multiple siblings that are having the maximum GCD, because the maximum GCD is nothing but 6, right? But if there are multiple siblings that are having the maximum GCD, so in that case, which father should I return? So in this case, if I'll observe, so it says that if there are multiple such nodes, then you have to return the node which has the maximum value. Okay, so in that case, you will return 3. Please write MX in the chat. Okay, if one is a, like, one is a father, right? If one is a father who is having the children with the maximum GCD, and 3 is also a father who is having children with the maximum GCD. So in that case, I'll compare the maximum of 1 comma 3. I'll compare the maximum of the fathers, or you can say the mothers, basically, right? If I will be gender neutral. So basically, I'll return 3. Is that clear to everyone? I'll return the maximum. Please write 3 in the chat or MX in the chat if everyone is clear till this point. Is everyone clear till this point? Okay. Is everyone clear till this point? Please tell me. Please give me a +1 if you are clear till this point, right? You can write, hit the like button as well. Then I'll proceed further. Okay. Is that clear to everyone, guys? Okay. This point is clear to everyone. Can we proceed further as well? You can give me a +1 in the chat if everyone is clear, right? Now, there's one more case, right? There's one more edge case, right? That we need to see, right? The edge case is that, like, what, like, I am talking about siblings, right? So this is a binary tree. I'm talking about siblings, right? So let us say that if there's a scenario of something like this, let's say that if I will talk about this kind of a scenario, so obviously this is a binary tree. So in this case, let's say that if I'm having something like this, let's say if this is the child, okay, and let's say after that there are several other children also, and the tree goes on and on, right? So now in this case, let's say that if I talk about this particular segment, right? So if I look for this guy, right, let's say this is the father, right, or you can say the mother as well, right? So it has only one child, right? This is the only child, this is the single child. Like, in that case, this is the single child, right? So in this case, this is the single child, correct? Yes or no? Please write yes in the chat, right? So if this is a father, if there is a father, right, if there is a root that has only a single child, either the left child or the right child. So other scenario can be, let's say there is a root and then I have this, like, let's say this is the father, okay, and this is the single child, right? If this kind of a case is there, so in this case I will not consider it. Okay, I'll not consider such kind of a circumstance. So what should I say in this case? I will say, in this case, I will say that I will check the GCD, right? I'll check the GCD only if for the current root, okay, if the for the current root its left child is not equal to null, okay, and the right child is not equal to null, okay, and the right child and the root's right child is not equal to null, okay. So basically, for this case, the root's left side should not be null, and the right should also not be null. Is that clear to everyone? Please write yes in the chat. Okay, basically, for checking, the condition is that the left child should not be null and the right side should also not be null. So both should exist, basically. Both should exist. Is that clear to everyone? Both should exist. Is that clear? Is that clear to everyone? Please hit the like button if you are clear to this point, right? If you are clear to this point, you can hit the like button. So basically, both the left and the right both should exist, right? Both should exist. Only then I will check. Okay, this much point is clear to everyone. You can hit the like button, guys, if you are clear till this point. Now, furthermore, what can I do? Right. So basically, what will happen here is I'll start a traversal. Right. So what I will say is, in this case, let's quickly try and write a little bit of code here. So I am given this particular root node. Okay. If as you can see here, I have been given this particular root node. So basically, what I will do here is, let's say I'll have a variable, let's say maximum as 0. Okay. And I'll also have a father, right? So let's say father. So let's say father. This father means that the node that I want to return as the final answer, right? So let's say I'm marking it as 0 initially as well. It totally depends what you want to mark. Then I'll have a recursive call. Okay. You can say it as a DFS call. I'm saying a recursive call on the tree. Okay. So I'll start from here. I'll start from the root node. Okay, and I'll pass my maximum and I'll pass my father as well. Okay, in the end, what will happen? My father will get updated. Okay, I'll have the father, which has the siblings which have the maximums. Like I'll return the father. Okay, who has children with maximum GCD, right? With maximum GCD, right? And if there are several fathers, then in that case, I'll return the maximum father of them out of them. Is that clear to everyone? Right. So after this function, my father will get updated, and the father will be chosen in such a way that the father has the children which have maximum GCD. Okay, and if there are several fathers which have children that have maximum GCD, in that case I'll choose the father with the maximum value. Is that clear to everyone? Please write +1 till this point if everyone is clear, and then I'll proceed further as well. Okay, till this much point everyone is clear. Right. Now, in this case, what I will do is, like, it will be a void recursive kind of call. Okay. So I'll say that, okay, void recursion is there. All right. Now, what I will do is, now I'll say that, okay, here what I'm passing is, I'm passing the root value here. Right. And another thing that I'm going to pass is int ampersand mx, because I'm passing it by reference so that any changes I'm making here should be reflected in the final answer as well. I'm passing the father as well in this function. Right. Now, can I say that if, let's say, if I go to a certain root, right, if I'll talk about the base case, right, if in this recursion, if talk about the base case, so what is the base case? Can I say that the base case is that if, let's say, the root, okay, if the root like is equal to null, right? If the root does not exist, right? If the current node that I am at, if it does not exist, so can I say that I can simply return from that call? Please write yes in the chat. Okay, if I keep on doing the basically the recursive traversal, and if I reach a particular node that is null, in that case I'll directly return because there is nothing else that I can do for it. Okay, because if that guy does not exist, so its children will also not exist, right? So I cannot do root left, root right. Okay, I should return. Please write yes in the chat. Everyone agrees with me on this point? Please write yes and hit the like button as well. Is that clear to everyone? Please tell me, guys. Okay, this much point is clear to everyone. Okay. Now, after this, what I will say is, I'll say that, okay, now if it happens, right, if it happens that the root, right, if it happens that the root, let's say the root's left guy, okay, is not equal to null, right? If the root's left guy is not null and the root's right guy is also not null, okay. So basically, if both the children exist, is that clear to everyone? Is that clear to everyone? Basically, both children should exist. In order to check for the siblings, both should exist, right? As I'm saying, both should exist. Since this is a binary tree, so both should exist. Is that clear to everyone? Both of the children should be existing. Is that clear to everyone? Is that clear to everyone? Both the children should exist, right? I'm checking that, okay. If both the children exist, in that case, what I'll do is I'll find the GCD. So in C++, what I can do is I can use inbuilt function for finding the GCD. In Java, you can write a GCD function of your own. Okay, I'm assuming that you know a little bit about GCD. So what we can do is, like, let's say I'm naming this GCD as, let's say, G. Okay, is equal to underscore underscore GCD of this thing of the roots left data. Okay, GCD is going to be what? GCD is going to be the for the current root. The GCD of its children is going to be nothing but the GCD of the roots left data and the roots right data. Okay, and the roots right data. Right. This is going to be the GCD. Now, what will I do? Right. Suppose that if the GCD, current GCD that I have calculated, if it is greater than the maximum GCD that I have seen so far. Okay. If the current GCD, let's say, if I'll talk about this, let's say this is the current GCD, right? Current GCD of the two people, two children, right? Let's name it as current GCD. Okay. If the current GCD that I have calculated, right? If the current GCD that I have calculated, if it is greater than the maximum, right? So in that case, can I say that I'll say that, okay, current GCD, right? In that case, I'll say that, okay, current GCD should get updated to nothing but what? Current GCD should get updated to the sorry, maximum GCD should get updated to the current GCD. Maximum GCD should get updated to the current GCD, and I will say that okay, now the father should also be get updated because this is the father that is having the maximum value. Please write yes in the chat, everyone. Right? If the current GCD, like basically the thing is that for the current root that I am at, both of its left and right children should exist. So both the left sibling and the right sibling both should exist, right? Both the left child and right child should exist. Then only these siblings will be there, right? Then only they will behave like siblings. So if they are existing, if for a particular root, if its left is also existing and its right child is also existing, so I'll say that okay, I'll take the GCD of the left child and the right child. That is nothing but taking the GCD of these two siblings. And if the GCD that the current GCD that I have got from these two children, right, if it is greater than the maximum GCD that I have stored so far, so my maximum GCD will get updated and my father will get updated as the root, okay, root data, because this is the particular father which has the children with the maximum GCD. Is that clear to everyone? Please write clear in the chat. Okay, please write clear in the chat. Is it clear to everyone? Is this point clear to everyone? Please tell me, and hit the like button as well if you have not hit the like button. Is it clear to everyone? Please write clear in the chat, guys. Okay. Now this is one of the cases, right? But suppose that else if it happens, right? Else if it happens that suppose that the current GCD, right? Suppose that the current GCD is equal to the maximum GCD, right? Is that clear to everyone? As I said, in this case, if you will observe, so suppose that it happens that there is a particular tree like this, and let's say this is the guy. Okay, let's say this is the tree. This is again another part. This is another part. This is another part, right? Let's say this is 6. This is 12. Okay, let's say this is 6. This is 36, and let's say this is 5. Let's say this is something like 7. Okay, so now in this case, if I will see, so what is the maximum GCD? Can I say that the GCD of these two nodes is nothing but 6, right? The GCD of these two nodes is 6. And can I say that similarly the GCD of these two nodes is also 6, right? So in that case, if suppose that the maximum GCD is already 6, okay, and these two children are all, like, and my father is storing, let's say father is currently stored as 5, okay, because 5 is a node which has maximum GCD as 6. Now if I am traversing and I see that okay, 7 is another parent that is having the children, that is having two children that have the GCD as 6. So in that case, I'll take the maximum father. Is that clear? Like, because in this case I can see that the GCD for these children is coming out to be 6 as well, right, which is the maximum. So in that case, I'll take the maximum father. So I'll take 7. Please write 7 in the chat. Instead of 5, I will try to take 7. Is that clear? Right. So in that case, is that clear to everyone? I'll take the maximum father in that case, right? If two father have children such that they have the same GCD, same maximum GCD, in that case I'll say that okay, if this is the case, right? So if it happens that the that my father currently that I'm storing, right, if it is having lesser value compared to the current root that is having this these two siblings, in that case my father data will get updated to the current root data. Is that clear to everyone? Is that clear to everyone? Please tell me, guys, right? If the current GCD that I've calculated, if it is equal to the maximum GCD, right? So if there are a couple of fathers that are having the maximum GCD, like that are having children with the maximum GCD, in that case I'll store the father with the maximum value now. So in that case, if this father that was already stored, if it is having lesser data compared to the current root, in that case I'll update this father with the root data. Is it clear to everyone? I hope it makes a lot of sense. Now, once this call has been done, right? So what will I do? After that, like, see, if you will observe, like, let's say that if I have done the call for a particular node, let's say if this is a particular tree, right? Let's say if this is the type of tree that I'm having, right? So let's say that this is the type of tree. Okay. So let's say that if I was at this node, right? For this node, if this was the left child, okay, this was the left child and this was the right child, okay, and this was the right child. So if for this root node, if I after for this root node, if I have done the processing, right, if I have calculated the GCD for this particular root node, if I have calculated the GCD of the two children, right? So after that, what will I do, right, guys? After that, what will I do? Can I say that after that I'll call the recursive call, like I'll call the recursion, right? And I'll pass this guy as the root, right? I'll also want this guy to be the root. So basically, what will I do? I'll pass the roots left as I'll call the recursion from the roots left also, because I want to see this guy as the father as well, and then I want to calculate the GCD of its children if they exist, right? Similarly, I'll say that okay, I also need to uh, have this guy as the root. Okay, I also need to have this guy as the root, for example, and from this guy also I want to calculate the GCD, right? So I'll call the recursion for the roots right as well. Okay, so I'll call the recursion starting from the root left and the right as well. Is that clear to everyone? Please tell me, guys. Please hit the like button if you're clear till this point, right? You can hit the like button if you're clear till this point, right? So basically, as we keep on doing that, you will keep on moving downwards, right, inside this. So once you have calculated it for the root, so now you will call the recursion for the roots left, and you'll call the recursion for the root right as well. Okay, is that clear to everyone? Please tell me. All right, so what will we do? We'll say that, okay, we'll call the recursion, and I'll simply pass the roots left guy. Okay, I hope that it is clear to everyone, right? This is pre-order traversal, right? Yes, it is pre-order traversal only. You can say that, but I'm saying it as recursive traversal. It's not necessary that you do this only. You can do any kind of traversal, I think, for this problem. Okay, then I'll pass the maximum and I'll pass the father as well for the left guy. Okay, so this is nothing but calling for the left child. Okay, now I'll call for the right child similarly. So I'll say that, okay, recursion of roots right guy. Okay, I'll pass the maximum and I'll pass the father here. Okay, so what I'm going to pass is I'm going to pass the father here. Right, so is this point clear to everyone? Okay, now there is one more thing that we need to understand in this problem. The other thing is that in this problem, if you will see, so they are saying that return zero if the tree is empty, right? So they are saying that if tree is empty, okay, if tree is empty, right? If tree is empty, then you should return what? Then you should return this thing, return -1. Okay, return zero if tree is empty. That is levels is -1. That is level of tree is -1. Okay, so I think in this case, if I'll observe, so what we can do is let's say that return zero if input tree is empty. Okay, so this is the edge case that if suppose that a tree does not exist, right? So if it happens that the root is equal to null, right? So in that case, simply I can do what? I think I can return nothing but zero here. Okay, so is that clear? Let's try and compile it as well to see if it works on the samples or not. See how it goes. Okay, it works for the samples, right? You can see that it is working as of now for the samples. Now let's try and submit it to see if it gets accepted or I have made any mistakes here. Okay, let's see what happens. I hope it should get accepted. Right. Okay, so this problem gets accepted. So is this problem clear to everyone? Please tell me, guys. Is this problem clear to everyone? Please tell me. Is this problem clear, guys? Okay, Rishit says clear. What about other people? Others are also clear with this problem? Okay, so talking about the time complexity of my approach. Before talking about the time complexity, let me summarize it again. Okay, so basically in this problem, it says that if the tree is empty, then you can directly return zero. Otherwise, I'm marking the maximum as zero and father initially as zero as well. Then I'm calling a recursive call, or you can say a pre-order traversal, and I'm passing the root here. Okay, I'm passing the maximum value and I'm passing the father as well. Okay, in the end, I have to return that father which has the children which have the maximum GCD. Okay, if there are several fathers that have the maximum GCD. So in that case, I need to return that father which has the maximum value, right? So what I'm doing here is, if the root is null, then I'm simply returning from here. Okay, if the roots left is not like, if the root is null, then I'm directly returning, right? Now the condition is that both of the children should exist for a particular root. Both its left and right child should exist, then only those children will be considered as siblings, right? So if the left child of the current root is not null and the right is also not null, so I'm taking out the GCD of those two nodes. Okay. Once I've taken out the GCD, current GCD. So if the current GCD of these two nodes, if it is greater than the maximum GCD so far, right? So in that case, I'll update the maximum GCD and I'll say that, okay, the father who is having who is having these children with the maximum GCD is this father, right? So the father will get updated to this current root data because this root is the father of these two children that has the maximum data. So I'll update the father as well. Okay. Now suppose that if the current GCD that I have calculated, if it is equal to the maximum GCD, right? So if the current GCD that I have calculated, if it is equal to the maximum GCD that is stored so far, so in that case, I'll say that, okay, if there are two nodes that have the children with the same GCD, so in that case, I will store like if there are two fathers that have the children that have which have the same GCD, so in that case, I will store that father which has the maximum value. Okay, so in that case, father will be equal. Like if this father that I'm storing, if this father data that I'm storing, if it is lesser than this current root data, so I'll update the father with this new maximum value. Okay, so father will get updated to this root data. Okay, and then what I will do is I'll call the recursion down. Okay, I'll call the recursion down, or I can say that I will do the pre-order traversal. Okay, basically first of all calling for the root, then the left, and then the right. So basically what I'll do is I'll call for the left. Okay, I'll pass this maximum, I'll pass this father by reference both these variables, and I'll call for the root right guy. Okay, I'll call the I'll pass the maximum, I'll pass the father, and that is how my recursion will keep on calculating the part. Is that clear to everyone? Is that clear to everyone? Is this point clear to everyone? Please tell me, guys. Okay, is this point clear to everyone? Is this question clear? Okay, and I think this particular question, as we can see, so it was asked in Samsung, right? So this particular question was asked in Samsung, and it was an easy problem as well, right? So this particular question was asked in a company like Samsung, right? And it was an easy problem, but I hope that you have understood this problem, right? So please make sure to hit the like button. Okay, please make sure to hit the like button. And after this video is over, or in fact in this video also, you can comment down understood as well if you have understood this problem and the concept properly. And make sure to subscribe the channel as well. Okay, and make sure to share it with your friends as well. Okay, I hope that this video was helpful for all of you. And space complexity in my approach is going to be order of n only. I'm not sure how it can be reduced. I did not see that, but in that case, maybe we can have a look at the editorial if you want, right? So let's see the editorial how they have done it. So let's have a look at the author's solution, right? Let me refresh this page first of all. Okay, so let's have a look at the author's solution in that case. Are they doing it without any extra space as we are not using? Okay, so traverse every node once. Okay, let's see how they are doing it. We can reduce using iterative approach. But in the solution, they have also given a recursive approach, right? So if you will talk about the recursive approach, so you can see that in the author solution, they have also given this approach. So in this case, you cannot optimize the space complexity because there is a recursive stack space that you are taking. So in the worst case, the recursive stack space will also take order of n time. Okay, and if I'll see the solution, official solution as well. So I don't think that they have done it without using this thing. Okay, this is a different problem, I think. Okay, because in this they have the array. So I'm not sure. Like maybe they might exist a solution, but if you will do it using see, there are two ways of doing this problem according to me, right? The first way is that maybe you can do it using BFS, right? Let's say, or you can do it using DFS. So if you will do it using DFS, then you will use recursion. Okay, so recursive stack space will be there, right? Recursive stack space will be there. That is order of n. And if you will do it using BFS, then you are going to use a queue according to me, right? And if you're going to use a queue, so that will be order of n in the worst case as well, right? Is that clear to everyone? So I don't think that you can avoid space. If you don't consider the recursive stack space, then maybe it is order of one, but maybe you might have to consider the recursive stack space as well. Is that clear? I hope that this approach and everything is clear to everyone, right? Okay, I've showed you both the sides. Maybe in the earlier problem they had this thing that was array, but now they don't have an array. They have a tree, so you need to traverse it either using BFS or DFS. That is the issue. Okay, if there's any other solution, then you can definitely tell me. With that being said, thanks a lot for joining. Make sure to hit the like button, guys, and make sure to keep solving the problem of the day. Till then, good night, take care, and happy coding. Make sure to solve the problem of the day for today as well. And bye, everyone. Thank you.